as I would like to introduce our next speaker to you. Josef Kriegmair, he is Project Director of the MTU Aerospace Engine. He works as a representative production turbine blade structure castings at MTU Aerospace Engine Center Production. His focus is on developing and implementing digital process chain, CAD/CAM methods, NC simulation solutions, manufacturing intelligence, etc., etc. So he will share with us some best practice and experience he implemented on the digital manufacturing environment. Please welcome Josef with me.
Thanks a lot for the introduction. Can you hear me?
Yes.
Okay. And I have organized my presentation in 3 chapters. In the first chapter, I would like to talk briefly about MTU Aero Engines. And the target from my side is to enable you to see my presentation in the context of the MTU Aero Engines production. And the company MTU Aero Engine had a revenue in 2016, year 2016, about 4.7 billion euros. And we had a workforce in last year, about 9,000 employees worldwide, made up of 48 nationalities. Okay, it works. MTU Aero Engines is a supplier of engine subsystems. We are not an OEM like the big ones, like Jet, Pratt, GE, and Rolls-Royce. We are a supplier of subsystems for several military jet engines. We are developing such systems, and we are manufacturing such systems. And we are a provider of maintenance, repair, overhaul services worldwide. And for civil and military jet engines, as well as for IGTs. It means for gas turbines spin-offs from a jet engine. Our facilities for manufacturing are in Germany and in Poland, and the maintenance, repair, overhaul facilities are worldwide. We are not involved in piston engines, like maybe a car engine. So I would like to switch to chapter 2. Probably it's a bit of a strange topic if you say the human-machine interface. You probably have heard a lot of presentations about Industry 4.0, the Internet of Things, digitization, and so on, state-of-the-art technology. And if you hear, maybe a bit astonished to see a track human-machine interface in an Industry 0 or 0 stream, and probably ask yourself, does it matter? My point is, it does matter. Perhaps you still think it's not important. Maybe you think in a different way after my presentation. So, if you talk about a smart manufacturing or a smart factory, it's a goal of many companies. The presentation before from ACOM was about the smart manufacturing. From my point of view, there are 3 basic elements. One, of course, is technology. The second one is the process, built or based on processes. And the third one are people and the workforce. People or workforce has to interact via processes with technology. And you need an interface how to do it. And the interface is the human-machine interface. So there's a lot of hype about technology and about processes. People talking a lot about these topics. So often do not talk about the workforce. My understanding is that smart manufacturing, a smart factory will have people involved in that factory. Now let's switch to a thing. Do you think there's commonality between a smartphone and Google? Yes, there's a big one. The big one is the outstanding user experience. The outstanding user experience brings people, or enables people to do intuitively the right thing. Have you ever used a manual for your smartphone? Or have you ever read a manual to do a standard Google search? Probably not. Probably you haven't. Now, I think the user interface has been a key success factor for Google. I'm not with Google. I have never been with Google. But I think it has been a big issue. Now, if you think about your shop floor, do you have a similar user experience with your ERP or with your other systems? Perhaps, perhaps not. I'm quite convinced that the user experience, the user interaction is a very important thing in an Industry 4.0 environment because people, workforce has to interact with systems. And the better the interaction is organized, the more productive you are. The rest of my presentation is about that interaction, the beneficial and effective interaction between technology, systems, and users, workforce. So what is the task? The task is to delight users. The user interface, the human-machine interface, has to provide the required functionality in such a way that people, workforce, is performing in the right way. That's the key topic. Now, it's not that easy to delight users by a human-machine interface. From my experience, there are a couple of elements which can lead to that user experience. But there are a lot of other factors too. The first one is that you have a few actions. The feedback I get from the shop floor is always, we want to do our job, you want to do with a minimum of effort. Make it easy, simple, fast. We do not have time to satisfy systems. We want to work and deliver parts. The easy to handle. Easy to handle means we want to do the right things without any training. Other thing is, to delight the user means to satisfy the real needs. But do you delight the user if you address the latent needs of a user? For instance, if I go back, Henry Ford at that time recognized that people are looking after improved or better mobility. The answer was not a faster horse, the answer was the Model T, an affordable car for the mass. If you think that way, maybe you change a lot of things in your shop floor. The other thing is the self-explanatory. For our users, they want to go to a system. They like to understand what's going on. We had a lot of experiences made in that area. Once we changed the user from one machine to another, the user interface was quite common knowledge for him, and he performed without training. It's now a standard. Often we try to do it to reach that. And the next thing is from that flow line, I bring an example later. People do not work on the same station every day. They rotate normally on a daily basis. Every day another job in that lane. And the flexibility of using workforce on different stations requires a good user interface. Otherwise, if you have a good user interface, people come in, maybe you have personnel from abroad or from outside the company. You normally have a need in manufacturing. Often in our cases, it's the case. You're much faster if you do not have a long training phase before they can work on the shop floor. A good human-machine interface supports that. What are the key success factors? One is, of course, is a deep understanding of the processes. It's, from my point of view, of paramount importance. It's necessary to understand the real benefits, the real requirements of the customer shop floor. The next thing is, system incorporates the complexity. What I mean, if you look to your smartphone, the smartphone is relatively easy to operate, like I showed before with the iPhone. And the complexities within the system. The user interface is relatively simple, but the system itself is very powerful. We have to bring it back to the system. The next thing, the system is resilient. That means you have a robust process, it's stable, it needs a low amount of maintenance, and whenever you do something wrong, it does not collapse. If you have ever worked with a non-stable system, it's a nightmare. And in the shop floor, they normally have to meet their times, they have to stay intact, so in time. Therefore, it's quite challenging. But what is the key issue in that area? The key issue, from my point of view, is the data architecture behind the system and behind the solution. Now I have a citation from someone from the Netherlands. He made a statement, data architecture, the bricks of tomorrow's project execution. The ACOM presentation before was about data architecture, data processing, how to organize the data. If you talk about smart manufacturing, smart factory, it's all about data. It's data to convert data to value. Data is in, value is in data. And the structure, you need a structure in order to bring it from data to value. For instance, the key to improve process is often in smart manufacturing the data. It's the raw material of the processing, then comes the result, and the result normally brings the benefit. Now, I address something very important. If you want to go to smart, so my experience, if you go to smart manufacturing, you have a lot of smart things. Smart things need a unique ID. Unique ID, like your telephone, there's a unique telephone number. You have maybe a unique ID if you maybe in some app store or something like that. And how to build such a unique ID within a system. One concept we often use is unique ID means type plus individual. Type means in our area often the part number, and the individual often the serial number. It means if you go maybe more to programming, the type can be the object, and the instance is the individual. A powerful concept, so my experience, gives you a lot of freedom how to perform data and how to transform it from the state you get it to value. Now I would like to show you an example. Very simple example. It's one example of a lot we have. The yellow screen or the yellow background you see that signals for a user, it's the start menu, always. The operation, here is said, okay, the job is the unique ID, and the type we scan, also the individual, and in order to stay resilient and flexible, some people prefer to work with touch, others prefer to work with a mouse and a keyboard, so we address different needs. With that simple device, we handle all parts, fixtures, tools, chucks of a flow of a smart manufacturing line. in two ways. We combine it, for instance, a part with a fixture, a chuck with a tool, or separate it again. The whole design is organized or optimized to a haptic that we can use to touch with a glove, because our workforce has to wear gloves in that area due to safety reasons. When you have a text inside here, it will disappear after a certain point of time if it's not processed by one of the buttons later explained. This guarantees that the data is always consistent, that no false data can be recorded. The buttons here you see, the green ones, the bubbles, state the system is idle. In case it's processing, it turns to red. The personnel always sees what's going on, what's important, what he has to do. So for the green or the OK button means go on, process the recorded data, and go to the next menu. The red cross or the cancel means erase the data from the input fields. The bin means separate two things, maybe a part from a fixture after machining, or a one-out tool from the chuck, and so on. On the triangle, show me the log, what has been going on the system. After processing, maybe you have checked pressed the OK button, a second screen appears. In this case, it's the blue background. The blue background always signals for user. It's the state where you have to check whether the processed data from the system is correct and is appropriate for my task. If it's yes, you can go on with the OK. If not, you use the bin and erase the whole job. The preferred way of doing that is touchscreen, and the keyboard and mouse is an alternative. In case the system has found a deviation or a conflict, it do not shows the blue background, it shows the red background, and the signals for a user who says a conflict. Again, he has two, or she has two choices. Says, okay, the conflict I know, it's correct, go on. Press the OK button. If it says no, cancel, something is wrong, you cancel it, everything is erased, the thing stops, you can start again. Again, the touchscreen is the preferred way of interaction. The keyboard and mouse is an alternative in case touchscreen doesn't work or whatever, do not like. Now, a statement. An outstanding user experience provides benefits, of course, from my point of view, in three areas. One in the quality area, less rework, better data quality. High data quality is, from my experience, a must in order to process data to value. Time, you're getting faster. One the other way, you have less time wasted for non-value adding tasks, and a cost. And now maybe it sounds a bit strange for you that I say the time goes outside and not inside. I've made it in that way because we gain time for more value adding tasks. So I said it this way and not the other way around. So the situation changed a bit. Okay. Now, I would like to summarize what I have said so far about the user experience, the user human-machine interface in 3 statements. Statement 1, people, some my experience, love to work with a system which is fault-tolerant, reliable, and meets their demands. Second one, the user has a good feeling whenever he works with a system which has some capability to adjust to his or her need. Next statement. The value of technology, so my experience, for an organization unit manufacturing per se is 0. The value comes with the use of the technology and the implementation in an appropriate and beneficial way. The third one, my experience is it's much harder to make something ingeniously simple than to incredibly complicated. So it's often a quite hard, often long and hard way to achieve that simple and ingeniously simple status. Now, the time has come for my last chapter of my presentation, and that's the Q&A. Thanks.
Thank you very much, and I think it's an absolute value point to see what is often forgotten, the interaction with the people and how to enable them to make their job in an easier way and more interactive. Any specific questions? Any specific points? Would you agree to my statement? Okay. Yeah.
I was wondering, today you talk about when it comes to HMI for production and running manufacturing. When it comes to running the engines that you produce, is there something that is already in place in airplanes, or is more still manual commands in order to operate the engine?
This is true for the machining equipment on the shop floor. The engines are a different topic. The engines normally are controlled by a so-called FADEC, full authority digital integrated control. I hope it's correct. I always know the abbreviation FADEC. It means the engine controller for a jet engine, and it's part of the control system of an aircraft. It haven't talked about this stuff. It was about shop floor, how to interact on the shop floor with technology.
There's a question in the background.
Yeah, hello. Thank you for the presentation. Where do you see human-machine interfaces in manufacturing going in the long term? I mean, today we're working with our eyes and we're interacting with our hands, just pushing buttons, basically keyboarding still.
Yeah.
Do you think that other sensors will come, like tactile sensors, temperature? Like, will the other senses of the human being be also used to interact with machines in the future?
My opinion is that they will come, but it's always, you have to think about your case, your task. So we thought about using a glove where can scan the so-called 2D matrix, but the process as we do it now, it's more valuable. It's easier for the shop floor. I think it will come maybe that you use gestures. Maybe some car manufacturer in near Munich is doing that for some visual inspection. Let's always think about the topic, and not each user prefers the same way of interaction. The time we started at the touchscreen, a lot of people said we do not like the touchscreen. We said, okay, we implement it. Now touchscreen is, since it's has been adopted to the topic, to the task, it's the preferred way of interaction. I think it will come.
And I would 100% agree to that one. So I strongly believe it will come. There is so much technology coming up which allows us to drive things in a different way. So it's getting more intuitive what we do and how we interact with the more intelligence machines coming or equipment as well coming along. So definitely yes. How quick that will go will always be a question, as you said. I mean, it's how quick are we willing to adopt the changes in our life? Any additional questions? All right. Then support me and thank you, Josef, for your presentation.